Okay, like I said, we're going to have to massage this schedule a little bit. This was what it was, and I removed all of the November stuff now. But today I am going to lecture on Chapter 7, but there won't be enough time for the test review, so I'm going to take the test review there and move that down to tomorrow. So I'm going to have here the test review, and that's what we'll do from 8 to 8:30. Then you'll do the course evaluation from 8:30 till 9, and then hopefully we'll finish we'll call it Lutz Pizza. And then if there's time, we'll go through some examples of OOP. Now, Monday, it's got in here that you're going to have the written test, but we just said we'd change that and we'd redo the hands-on test for chapters 5 and 6. All right? So all this stuff is going to be moved down a day, and that's why I said you're probably going to lose that Friday. Sorry about that, but you'll still have 1, 2, 3, 4, 5, 6. If we can gain some time, we'll try to gain it. All right, I'm on Chapter 7 now, so I'm on page 452. And what I'm going to do is I'm going to go back and forth between going what's in the book here and giving you some of my own notes that I'm going to put out there. All right? Some of this stuff I may have told you already. Sorry, it's not that I'm trying to tell you the same stuff over and over again, although repetition's not a bad thing. I'm not trying to do that. But the first thing, and I'm going to make this nice and big, that I want to do is draw a distinction between object-based and object-oriented. Again, we may have talked about this before. The reason I want to talk about it is this is JavaScript. This is C#, and it's going to be Java also. All right. Now, as far as what is object-oriented, that's in your book, so I'm not going to repeat that stuff. I'm going to go into it in just a minute. But what I want to mention to you is JavaScript is what's called an object-based programming language. C# and Java are what are known as object-oriented programming languages. You say, well, I don't get it. Then give me a second. So far in JavaScript, we've done almost nothing at all that's object-oriented. That's truly object-oriented. We've done almost nothing. That's going to change in this chapter. All right? When we get to Java and C#, everything that you do is going to be based on objects. But with an object-based language, what it means is you have object-oriented capability, which you can choose to use or not use. With an object-oriented programming language, you must use the object-oriented capability to do everything. Do you understand the distinction? All right. So keep that in mind as we start. So explain basic concepts related to object-oriented programming. That's what we're going to do first. Talk a little bit about the date, number, and math objects, and then finally learn how to define your own types of objects. What's in here is basically what I've told you. We've done a little bit of work with object-oriented because you've done stuff like, for example, document.write, which means it's the document object and you want to use what's called the write method, W-R-I-T-E method, to write something on your screen. That's object-oriented. All right? In a true object-oriented programming language, and I'm going to jump back to it in just a second, but I think they showed it in here. Okay, that's not it. They didn't show it the way I thought they were. That's fine. All right. Now, again, I'm going to give you some examples, which I think it's sometimes easier to not give you computer-based examples. All right, so I am a developer. So imagine I'm a developer, and let's assume that out there, that if we looked out that window, it's not the case, but we're going to pretend. There is a 100-acre plot of land that's for sale. All right? I've got the means to buy it, so I buy it. And what I'm going to do is I'm going to put up a huge neighborhood with 100 houses in it. Each house will be on an acre. Let's not worry about streets or anything, just bear with me. So each house is going to be on an acre. I'm going to have 5 house plans. Okay, house plan 1, 2, 3, 4, 5. Let's just say that they're different. Some are ranches, some are 2 stories, some are raised ranches, etc. You get the idea, correct? And the way I'm going to lay them out is it's going to be house plan 1, then 2, then 3, then 4, then 5. Then in the next row, it's going to be 1, then 2, then 3, then 4, then 5. You all get the idea. That's how we're going to build our neighborhood. All right? So if I do that, each one, for each house type will have a blueprint. All right? Because I don't want the builder to just come in there and start digging holes. Does that make sense? My guess is whether you live in a house, an apartment, or whatever, even if it's an apartment, I live in an apartment. But they didn't just build that. Some architect drew some specs up, and they were approved, etc. All right. So again, why am I telling you that? Because each house, let's say that we've got 5 house plans, but let's just worry about house plan 1 right now. So let's say house plan 1 will be a ranch. It'll have 3 bedrooms, it'll have 2 baths, okay, etc. And it'll have a basement. All right. So it doesn't matter which of those that you buy, but as long as you buy a house plan 1, it'll have that. So why am I telling you that? Because each blueprint is a class. That's what it is. That's what a class is. It's a blueprint. All right. Now I know that before Kroenke, is that his name? Kroenke, whatever the hell his name is. Before he left, St. Louis was going to build a brand new stadium somewhere downtown, correct? It was going to be like $100 million or whatever it was. But do you think that they would just announce that and that day they would start bringing in trucks and digging holes? I don't think so. I think somebody would have made a model first of what the stadium would look like. Do you agree with that? They would have shown the model to people. They might have even programmed the model, etc. All right? That would have been a stadium class. So a class is a blueprint for the way you want things to look. All right? We're all parts, all right? We're all members of the human class, the person class, whatever you want to call it. Okay? Does that make sense? All right. And so each blueprint would be a class. Each house is an object. So an object is what's called an instance of a class. Creating objects is also known as instantiation. You are creating an instance of a class. So you are instantiating a class. So, depending, and I don't want to say this because if you're an atheist, I don't want to get you mad at me, but let's pretend that we're all God-fearing people in here, all right? And I don't care what God you worship, it doesn't matter. But let's just assume there's a God, and God one day created a class that he or she was going to call humans, okay? And decided that each human, he was going to make it simple. There were only going to be 2 classes of humans, males and females. All right? But both classes were going to have virtually the same things in common. We know what's different. I'm not going to get into that. I'm not trying to be funny here. But what I want you to understand is what a class is. A class is a blueprint. From the class, you make objects. Objects are instances of the class. Just like with the houses. I could make 20 instances of house plan 1. But one house might be gray. The next house might be green. All right, one might have a blue door, one might have a brown door. That makes sense? But they're all the same class. Just like, for instance, let's just say humans. We won't say males and females. Let's just say humans. We all have an eye color. We all have a hair color. We all have a height. We all have a weight. So we have things in common, but the values of each one of those is different. Yes?
So like a car?
Yeah, you could literally make any kind of class you wanted. Yeah, you could make an automobile class, but it gets to be even more complex than that because you could make a vehicle class, and then a car would be a type of a vehicle. You know, just like a boat is a type of a vehicle, and a truck is a type of a vehicle, and a motorcycle is a type of a vehicle. And then once you get into cars, you could say, okay, what kind of cars? A sedan, a station wagon, etc. So when you start doing that, what you do is you're starting to make what's called basically a class hierarchy, literally. You could take any company that does anything, and you could take what they do and make it into a hierarchy. We got a hierarchy at Rankin. Stan Schoen is the president of the college. He's in St. Louis. Don Pohl is the vice president, so as you start working your way down. And under Don are basically all of the different deans. All right? You can do the same kind of thing when you're programming. And that's what object-oriented programming is all about. All right, now maybe that was a good explanation, maybe it wasn't. But they talk about this in the book here. And they say, object-oriented programming is a creation of reusable objects that you can incorporate into multiple programs. And if that confuses you, think of it this way. Let's assume that I'm an independent contractor and Enterprise contracts me. They don't like the way their order entry system works right now, so they want me to redo it. So they contract me, and let's say I've got a company of programmers, so all of our programmers, we all do it. We get it done, they're very happy, and they like the way that it works. All right? Now, one of the people who works at Empire, or whatever it's called, Enterprise, that works for the rent-a-car place, knows somebody who runs one of the hotel chains in town, let's say Holiday Inn. And they say, wow, you know, reserving a car and reserving a room, they're not that different. So now I can take that reservation system that I made, you know, tweak it and be able to use it also not only for cars but for hotels. Does that make sense? That's because I've made a class, and from that class I can make reusable objects. If that still confuses you, think about it this way. I could make a bank account. All bank accounts have something in common. They all have a person who has the account, so they've got a name, etc. They all have a type. It's a savings account, it's a checking account, it's some other type. But there are different types of bank accounts. So I can make a generic thing that says all bank accounts have this. Then I could base other things off of that. That's what object-oriented programming is about. Now I mentioned a person. So if we said that a person, and I'm just going to keep it simple. Let's just say we give them a height, a weight, I'm going to give them 3 things, and an eye color. All right, we're saying all people have those. These things are known as typically these things are known as typically as attributes. Sometimes they're called characteristics, but typically they're called attributes. Now, we also say that each person can eat, they can drink, and they can sleep. These things right here, these are called methods. And it's confusing because even though they're called methods, when we write them in JavaScript, we still call them functions. We still use the name function. So what's the difference between a function and a method? A method is just a function you write inside of a class. All right? And again, when we see some examples, hopefully it'll make a little bit more sense. But attributes and methods. And if we created a person, and that person would have a height, a weight, and eye color, they could eat, they could drink, they could sleep. You say, oh, what about belch, for example? They couldn't belch. They can only do what we give them the power to do. They only have these methods, they only have these attributes. So you have to make sure as a programmer that if you're being assigned a task, that you're constantly in interaction with the people that you're working with to make sure that you put in all the attributes they expect and all the methods that they expect. All right? And that's what they're talking about in here. They say objects are also called components. Remember that because I think that's on the test. So an object is also known as a component. All right? Right here where I call them attributes or characteristics, some books also call that the data. All right? All right. Now, they try to use this in real life. And kind of going back, and I don't know if this is what you meant or not, Drew, but you take like an automobile. An automobile, so if you have an automobile class, and let's just say, I drive a Hyundai Elantra. Let's just say we made an Elantra, okay? That class is going to be made up of a lot of other classes because a car is made up of what? Tires, doors, an engine, etc. So you oftentimes have a class that's made up of other classes, and that's what they're talking about here. But these classes have to be able to be put together. And the example that they give in here is they say, suppose you're building your own home entertainment system. If you walk into a place, I think you'd all agree with this, and you say, hey, I want a home entertainment system. They're probably going to try, they'll size you up and think, well, he looks like he's a rich guy. And they're going to try to sell you the best one they have, correct? That would make sense. That's business. Well, they do this, and they give you this, and they say, here, oh, you want these speakers. And they're trying to sell this to Amin. And Amin says, well, I don't have to. I've got my own speakers already. I like the rest of the stuff, but I already got my own speakers, and they're good ones. Well, they might ask them, et cetera. Oh, yeah, those will work. Doesn't that make sense? Or you might decide that you're going to buy, and maybe you're going to buy yourself the coolest computer system ever. All right? So you buy one part of it at Best Buy, you buy another part at Walmart, etc. And you put all the pieces together. That's what you're able to do with object-oriented programming. It involves you creating classes from which you create objects, and those objects can communicate with one another to get things done. That's what the whole thing is about. All right? And they're mentioning, here's the difference, that in the past we've done, basically, we've done this. You've created, you've done some stuff, but it hasn't been objects. It's just been code. You've either used your own code, or you've grabbed some code, square root function, for example, or a random number function. All right? But now, your program is going to be made up of all these different pieces. It could be as small as just one object, or literally as large as millions of objects. Geez, I couldn't write something with millions. No, you'd be part of a team that would be doing that. All right? Objects are encapsulated. Now, go back to this. All right? I want you to understand the difference between two terms. Oops. And that is the terms interface and implementation. Okay? Now, I'm going to very easily be able to show you the difference right here. Don't worry, it's going to come right back. All right. Anybody want to take a guess? Is that an interface or is that an implementation? It's an interface. Why? It's visual because that's your impression of it. All right? Now, I'm going to type in 893 and I'm going to hit the square root button. How did that happen? But I'm talking about literally, what did the computer do to make that happen? I don't know. I don't have a flaming clue, and I don't care. That's the implementation. So the interface is what you show to the outside world. The implementation, you hide as a programmer, because you don't want other people to screw it up. The other thing, too, is if tomorrow somebody comes up with a brand new way to do square roots, as long as my interface looks the same, I can take my whole implementation, yank it out, put in the new one, and you're not the wiser. Maybe it finds the square root even faster. Instead of taking 3 millionths of a second, it only takes 2 millionths of a second. All right? So, the interface is, for lack of better words, what you show the world. And the implementation, that's the code that makes the interface work. All right? And again, you're not going to find these exact same definitions in the book. I'm just trying to explain it to you in a way that I'm hoping they make sense to you. All right? And the big thing about object-oriented programming is code reuse. And code reuse equals less costs, equals happy managers. That's what's driving all this. Because if you use object-oriented programming, you can write more generic code that you're able to reuse, which should save you a lot of money in the long run, which should make management happy. All right? And it might not just be managers, it might be stockholders, it might be something else. So encapsulation, as it says, all the code and data are within the object itself. They're hidden. You just see the interface. The idea of hiding that code is also known as information hiding, and it's also called the black box. And the black box, where that verbiage came from, is, whether you realize it or not, what powers this computer right here is a CPU that's about the size of a postage stamp. All right? And why does that matter? Well, one thing is, this is an Acer machine. Acer doesn't, would probably void the warranty if I took it apart and said, well, I just wanted to see what the CPU looked like. So I took it apart, took it out, blew on it to make sure there was no dust, and put it back in. Now it doesn't work. Fix it for me. All right? No, because that's hidden from me. That's away in a black box. In the same way, if I want to print this and I do a Control P, it brings this up. All right? But I don't have a clue. I'm not going to hit it, but if I hit print right now, I don't have a clue as far as what happens between here and there. I only care if it doesn't print. My interface is right here. It's showing me what it's going to print. The implementation is what literally happens once I click the button to make it print. All right? So you have to be able to understand the difference between an interface and an implementation. All right? And they use the calculator there. So the object is the calculator, you're the program, for lack of better words. All right? So they say, well, in JavaScript, the document object is encapsulated. So all that DOM stuff we've been doing. All right? I know that, Brady, I think you'd asked me that during, we talked a little bit about that during the first break, using that query select all, for example. All right? What happens internally in the computer? No one knows. Because it's like when I tried showing you those pictures of the DOM. Where is that? You don't see that picture of the DOM. You can't bring it up on your, you can't take a document that you've done and have it literally render for you the DOM. It's just something that the system does for you. But the implementation for that is hidden from you, and you can only see part of the actual interface. So the author is trying to show you that you've actually sort of been using that so far. All right? And we will continue to. All right, then they give you some other examples, that's fine. Then they talk about what an object or what a class is, or what an instance is, and what instantiation is. I already mentioned that to you. One other thing that's important with this is the concept of what's called inheritance. What we're going to go over next week, and I don't know when, but we're going to go over it sometime next week, is, okay, I make a class called person. And underneath that, I make a class called employee. And underneath that, I make two different types. I've got here, let's say, manager, and we'll call this hourly worker. What I'm showing you right there is inheritance. An employee is a person. A manager is an employee. Since an employee is a person, a manager is also a person. Does that make sense? This is how many companies set up. All right. I took a class years ago from a guy, and maybe I told you about this, that he worked at Johnson Controls. They make these thermostats. And they decided that they were going to take everything that Johnson Controls did, everything, and they were going to convert it. It was like a 5-year process and make it all object-oriented. One of their managers went to a conference and said they could probably eliminate 30% of their staff by doing that. Well, that didn't make the programmers happy, because that's who they were basically going to get rid of. All right? But the point is, he told us that after 2 years, they were 500 levels deep in their hierarchy. So imagine this. This is 3 levels. Level 0, level 1, and level 2. They were down to level 499. All right? So depending on the complexity of where you're working, what you're doing, this can be really, really complex. But it's inheritance. Now the difference, it's based off of human inheritance. And again, sorry if I keep giving the same types of examples. 2 people get married. Let's assume they're one's a male and one's a female, for lack of this story. All right? And let's say the 2 people who get married both have big noses. And I mean extremely big noses. Now they have a child. There's probably a good chance that the child will have a big nose. And it doesn't always happen, but it's probably going to happen that way. All right? Well, what can the child do? Live with it, wait till they get older and have a nose job, but it's not like they can take their nose, take it off, and put one they'd rather have on, correct? That's what you can do with inheritance. Because what happens is, I define a bunch of stuff up here that all people have. Then I define stuff here that just employees have. So this might be a name, an address, city, state, zip. This might be a department that they work for, etc. Then this would be stuff that just managers have. All right? This would be stuff that just hourly workers have. So this might be like hourly rate, hours worked, etc., where that would be, a manager doesn't make sense. Manager might be a salary. So that's what they're talking about in here. All right? All right. And they talk in here, they mention on here that, as it says, here's JavaScript has 13 built-in classes. Here are 6 or 7, 6. Arguments, array, Boolean, date, error, and function. And on the next page are the rest of them. You don't know, I don't think that's on the test. But there are 13 built-in classes. If they don't do the job, you can create your own. All right? So, if you create your own, the simplest way to create your own is to make something that's of type object. And you're going to see that in just a minute. All right? Now, you haven't exactly done this, but we've done something similar to this. So imagine instead of what they have right there, instead of that, we were generating a random number. So we said math.random, okay? It's the same type of principle. What we have here is we're going to read in a radius. And we want to figure out the area, which is the mathematical formula pi radius squared, okay? So what they're saying here is math.pi. What the heck does that mean? That means that there is a class in JavaScript that's called math. And remember before when I showed you like person and we had height, weight, etc.? One of the pieces of data that the math class has is something called pi. It's got a value of 3.14159 to a certain number of decimal places. All right? And one of the things that the math class can do is it can raise something to a power. This is squaring. So that would be, what you're seeing here is this is the math class dot the name of an object. I'm sorry. The math class dot the name, this isn't an object. It's the math object, and then under the math object is the name of a piece of data. All right? This is the name of a class dot, and it's the name of a method. In order for the POW method to do something, it needs information. What do you want and how many times do you want to do it? If this had been R8, that would have mean, instead of saying radius times radius, it would have been radius times radius times radius times radius 8 times. So what they're saying is, these are examples of built-in JavaScript classes and objects. All right? As we go on, we'll create our own. Now, what's kind of neat is, everybody remember this? When we did arrays? That would create a brand new empty array. That's one way we can do it. All right? Well, what's kind of cool is, when we do an object, it looks almost the same, except now we use curly braces. Please make sure you use curly braces there and not brackets. You use brackets and it's an array. You use curly braces and it's an object. All right? So why does that matter? Because with objects, they can do anything you give them the ability to do. So imagine you were creating an ideal person object, and you wanted to give them the ability to fly without an airplane. In other words, they could flap their wings and get from here to, or teleport, or whatever. All right? Any object has the power, any object that you create has the power to do anything you programmatically give it the power to do. All right? That's the key thing. And any built-in JavaScript object has got the ability to do anything that JavaScript gives it the ability to do. But what's cool about JavaScript that isn't about other languages, remember those, I just showed you this? These things, I said there were 13 of these. If Ethan comes in and says, man, I wish the math object could do this, you can give it the power to do that. You can add things to existing JavaScript classes if you want to make them do things they weren't designed to do. All right, so if you figured out something brand new that wasn't in there, you could do that. All right, and your own objects will do everything that you put in the class that you tell them that you want them to do. All right. All right. Now, they talk in here about garbage collection. I may or may not have talked about that before that. The whole idea is when you start to create things on your own in a computer, that if you've got programs that run continuously and you keep creating this and you create this and you create this, even if you've got a boatload of memory, all right, you could exhaust all of it if you keep creating stuff and you never remove it when you're done with it. So when you're done with an object and you remove it, I mean, think about it. How would the earth be? I don't want to sound morbid here, but if we didn't bury dead people or cremate them. So when people died, we just left them there. We'd eventually run out of room. I at least think that we would. All right. And what they're talking about with garbage collection here is when you are working with things in a computer and you don't need them anymore, you tell the system you don't need them. So in other words, if I come through here and I do this, so I say var person equals object. I gotta spell it right. Object. And I give it a whole bunch of stuff. So again, I'm just going to put ... here. That's a bunch of stuff. Boy, oh boy. And now the person can do all of that. The person can do all of that stuff. Okay? Now I'm done with it. And I don't want the person to be able to do anything anymore. So now I can come down here and say person equals null. That means take everything that's in that object and I don't need it anymore. And send a message to the operating system that the next time that you're coming through and you're cleaning out memory, I don't need that anymore. You can have that memory back. Does that make sense? That's garbage collection. You don't have to worry about it because it's done for you automatically. As long as you set something to null, it'll be done for you automatically. But if you don't, things can live on forever. So if you've got a program that lives forever, it can literally live forever. So they show you this within the guys. This is what you're working on in the chapter. I believe you're doing this ticket thing for outer orbits, which is a little bit, no pun intended, a little bit out there. They're taking reservations for people who want to space travel. All right? The day will probably come when you'll be able to do that. I don't think I'll be on this earth when that happens, but it'll probably happen. All right. So they mentioned some of the built-in classes here. And one of the ones is the date class. These are things that you can do with dates. Doesn't look like much, but you can break them up into individual pieces. So I can set up a brand new date, and then I can do anything I want to do with it. Anything that's in that date class. Now, do you remember, and I thanked Brady for this, that I talked to you about that place, that website that was called hunlock.com, and he found where it basically they closed it down, but they archived it. And if you still have that URL, you can look on W3 Schools also. But they'll show you all of the different methods that are available for the date class. All right. In fact, if I come out here and do this, whoops, I guess I was there, and I type in JavaScript date class, one of the first things that's going to come up is W3 Schools. Well, I guess the first. So all these properties, that says the date automatically has this stuff, and these are the methods. So those are the things you're automatically able to do with a date. All right. And they go through some stuff that you can do, just the same thing I just mentioned to you. Grab my book here. I'll make sure I don't miss anything. So you go through a very long exercise when you do all this stuff. And that literally gets us, like I said, it's long. It's about 10 pages or so long. And I'm jumping all the way up about 12 pages to page 480. All right. And now they give you some of the stuff for the number class. So you do a bunch of stuff with dates, then you'll do some stuff with numbers. Anytime you see something with the word to in front of it, T-O, it means you're converting something. You want to convert something to locale string. What the heck does that mean? If I want to write a program that's able to be used worldwide, I can use to locale string. So it'll come out and it'll show it in French if it's somebody in France. If it's somebody in Spain, they're speaking Spanish, etc., that kind of thing. So it's some kind of a conversion that you're doing. There's some number class, these are some number class methods. Here on the next page are some number class properties. Again, properties is another word for what I call data or attributes. All right? Here's some math properties or math. Let's look at some math methods, I guess, on the bottom of page 483. Now, most of these you never have to use. Anything with, those are absolute value, you might have to use that, but cosine, sines, depending on what you're doing, if you're doing something along more of the scientific realm, you might. Okay? Then on the next page, they've got some more. These are all things, some of these we've looked at already, some of them we haven't. Then there's another very long exercise in here. And that jumps us all the way to page 490. Because this is the second half of the chapter. This says that's fine, but what do you do when you don't have an object of your type? Okay? So let's say that there doesn't, you want to write a program and you want to do something with automobiles. And you don't have an automobile object. So what do? You create your own. And then it does everything you tell it to do, and it's got the ability to manipulate anything that you give it the ability to manipulate. And it manipulates it the way you tell it to manipulate it. The first thing they mention in here, I'm not going to read a lick of this, but all that stuff you see in blue, they're saying that JavaScript is object-based and not object-oriented. That's how I started, but that's what they're saying in here. But again, JavaScript allows you to build your own custom objects. So they start to show that. There are different ways that you can do this. One way is to do this. Okay? So you could either say this or you can say this. So let's say I was going to say person here. I could say var person equals new object, or I could just say var person equal curly bracket, curly bracket. Either one of those would work. You're going to see some of these next week because I'm going to show you some examples that I've done. I've plucked them out of different documents and stuff and made some changes to them. All right? Well, then why does that matter? Because on the next page they say, you know what? What you need to start doing on 492 here is you need to start creating a custom ticket object. Okay? So this looks a little funky, but if you please look on the screen, this is the most important part of the chapter, is right in here. Okay, in here, the stuff that they're showing in there, these are everything that we're going to let our performance ticket object do. They will have a name, they will have a customer name, a performance name, a number of tickets, and a date. Does that make sense? That's all that they have the ability to do and work with right now because that's the only thing that we've given it to work with. All right? And it looks a little weird because it's the name of your field or your property or attribute, colon, then the value. Name, colon, value, name, colon, value, name, colon, value. You'll notice if they're strings, they have to be either in double quotes or single quotes. If they're numbers, they can't be. And they can also be objects. Again, I may have mentioned this kind of thing to you before. Let's say that I make myself a clock class. Well, what would I put in a clock class? Hours, minutes, and seconds, right? And what would I allow it to do? Tell the time, set the time, change the time, that kind of an idea. All right. Now I decide I want to make an alarm clock. I could start all over again, but isn't an alarm clock a class? So if that's clock, wouldn't that be alarm clock? So what I could do is I could say alarm clock. I could make, if I make one of the members in here, one of these members, a class itself, that's called an aggregation. All right. Is that on your test? I'll let you know tomorrow. I don't remember. So they start showing how all this stuff fits together. This is what we want to be able to create. Everything that they show in here, you could do it without objects, but it's more work. And it's not as reusable as if you do it using objects. Again, I can't tell you too much about this idea of reusability, because that's what the whole thing's about. And then you go through and you're doing this exercise on 492, 3, 4, 5, 6, 7, 8, 9, 500, 1, 2, 3, 4, 5, 6. And I'm going to go up all the way to page 505. On the bottom of the page. Well, again, any object you create can have any method you want it to have. So if for some reason, again, this is a silly example, but it just came to mind. Let's just pretend that managers breathe differently than any other kind of employee. All right? So up here, I might define breathe as one of the methods. All people breathe. All right? So that means employees breathe. That means that hourly workers breathe and managers breathe. But I could go and I could do what's called override the breathe method. I could say managers breathe differently. They breathe through their butts. All right? I'm talking like somebody who's never really been a manager. All right? Don't tell Charles I said that. So, because I guess he kind of is the person they report to. Not all of them do, but I've worked for several that do. All right. So it says there are two ways you could add a method to an object. All right. It says you can provide code for it, or you can reference an external function. So in other words, I can put a function right inside of my object. There would be some code in here. So not only here do I have, properties, but I can put my own methods inside of there. The problem is sometimes when you create an object, and then later you're like, darn, I wish employees could do this. And I don't really want to go back into the original object and rewrite it. There's another way you can do it also. It's by using something called prototypes. All right, we're going to get to that in just a second. So there's another exercise that's on 506, 507, 508, and 509. All right, I'm going to go for about 2 more minutes and we're going to take another break. And on 509, the author starts showing you some of this stuff. All right, so here what he's doing is he's basically saying, okay, I'm going to create this variable. This is an object. It's called ticket 1. There's one passenger, and I want to be able to calculate the cost. And here, this is another object that's called ticket 2. There are 3 passengers. And we're imagining here that for this space flight, that everybody who wants to go on the space flight, it costs you $250,000. It's not, this is what they use in the book. It's not mine. So when we're calculating the cost, this one would be 250,000 times 3. Does that make sense? Because there's 3 people going. So it'd be 750,000. This one would be how much? How much would that one be? How many people are going? How many people are going? And if it's $250,000 a person, how much does it cost? $250,000. All right? And you say, well, that's simple. And you're working with a dumb piece of hardware. You have to let it know exactly what you want it to do. All right? I told students once, there was, you ever read a magazine where they come to the end of the article and they got a little space, they put in a little filler story or a little something like that? I was reading this thing once, and it was, I thought it was kind of cool. It was called Pearls of Wisdom or something. And they said what this teacher decided to do was that people in their class, there was a class of younger kids, maybe second or third grades. They were being really rambunctious, as they say. So what the teacher did was found a picture of a map of the United States and actually tore it up, basically, and had them put it together by states, and thought this will take them the rest of the period. All right. Well, one kid about 2 minutes later came and gave the teacher the thing, and she's like, "How'd you do it so fast?" I said, "Oh no, you missed it. When you turned it over, it was a picture of the world." And once I did that, it was real easy to put it together because it was a globe, but it was the way it was set up, it was real easy. So the idea was, once you put the pieces together and you see the big picture, it's not that difficult. That's what they're trying to do in this chapter, is they're trying to show you this from like a 35,000 foot angle. You're looking down on it. But there's so much more to this than they get to in the book. All right? And, so you might say, well, that's fine, then why are we even going over it? Because next semester, we don't have to now. I don't have to tell you in C# what an object is. Because an object is an object regardless of what language you're using. All right? All right. Let's take a break. Oh, in fact, you know what? We got 3 pages left, so let's finish the chapter. So I'm going to jump up to page 514. This is the other way you can add things. You can use what's called the prototype property. And what that means is it says if you've got an object, this is like I mentioned before. So you use the JavaScript number object, and then you can do all that number stuff. But man, I wish numbers could do this. I add my own property to the number object, and now it can do that. The way that I do that is I use what's called the prototype property. All right? And I just say, what do I want it to do? Dot prototype, and then I just define what I want it to do that it wasn't doing before. All right? And it seems, again, if it seems like this has just been a weird chapter, I haven't gotten a single thing he's talking about, the idea is you're just being introduced to this. All right? What I'm going to do, I'm going to look at Evan's test, but I'm not going to use his. I'm sure I'm not. Because your last test that you're doing here in Chapter 7 and 8, it's all going to be on Chapter 8. So the only stuff I plan on going over, for this is the written stuff. All right? So the good news is we're done with the chapter. All right? So let's take a break. When we get back from the break, there's 2 things I'll be able to do. First, we'll do the test review. Then afterwards, I'm gonna email you something during the break. Okay? And then we'll look at that after we go through the test review.